Thank you, Dr. Teutsch. So today I'll be talking about the nutrient status of Kentucky's alfalfa stands. So to give you a little bit of background information, most of you probably already know this, but alfalfa is a perennial forage legume that tolerates a wide range of growing conditions. It's most commonly used in the dairy and equine industries. And alfalfa yields, as you can see from this graph, grew exponentially from between the 1950s and the 1980s. Most of that is due to the invention of synthetic fertilizers, pesticides, and novel varieties. But in the 1980s, alfalfa yields plateaued in contrast with other crops like corn and soybeans. So the objective of this study is to determine the role of soil fertility in the observed yield plateau. So what did we do? This project is part of a multi-state project, and 50 fields were sampled in each Kentucky, Oregon, and Wisconsin. So today I'll be presenting the data from the 50 Kentucky fields we sampled. We sampled fields between 1 and 5 years of age, and all the samples came from a 20-foot by 20-foot area that was representative of the entire alfalfa stand. And we targeted sampling between the late bud and early flowering growth stages. So we took some soil samples at 4 inches, 6 inches, and a foot, and we split those samples, and there were samples analyzed at the University of Kentucky, and then samples analyzed through Kansas State Soil Testing Lab. We also took some tissue samples, so we took the top 6 inches of 30 stems within our sample area, and we dried and ground them to pass a 1 millimeter screen, and all of those were analyzed at the Kansas State University Testing Lab. We also did a yield measurement where we took 6 quadrats, 20 inches by 20 inches each, and weighed those. And we took a subsample for dry matter and forage quality analysis. We also went back into 3 of those quadrats and counted all the stems in a foot by foot squared. And then we measured the height of the stand in 6 different locations throughout the sample area. So just to kind of show you where our samples came from across the state, each of the counties with the star is a county that we have a sample from. We ended up getting 53 total samples. And here's some of our just summary statistics before we dive a little bit deeper into the data. As you can see, we got the minimum, maximum, average, median, and then the standard deviation. However, I want to focus on the median. And you can see the pH was 6.7, which is pretty close to the recommended pH in University of Kentucky's AGR1, which is 6.8. The phosphorus was 109 pounds per acre, which is considered high according to AGR1's nutrient status. And then the potassium was 260 pounds per acre, which is considered moderate for an AGR1. Then you also have the median at 6 inches. Once again, the pH is kind of close to the target pH of 6.8. The phosphorus was considered high according to AGR1, and then once again the potassium was considered moderate. And then in plant tissues, as you can see, 0.2 for phosphorus, 2.45% for potassium, and 0.31% for sulfur. And if I remember correctly, the phosphorus would be sufficient through the University of Kentucky's recommendations. The potassium was high, and then the sulfur was sufficient. Oop, went too far. So here's the soil samples by nutrient status, and you can see that for phosphorus, most of the stands were considered high at the 4-inch depth, and then about 20% were considered medium, and then somewhere around 1 to 2% were considered low. But once you go to the 6-inch, that decreased pretty substantially, and only about 55% of the stands were considered high, 40% were considered medium, and about 5% were considered low. And then in the potassium, about 35% were considered high at the 4-inch depth, with the same being at the medium for the 4-inch and the 6-inch depth. And then about 25 to 30% were considered low at the 4-inch depth. And then at the 6-inch soil testing depth, we had a couple stands that were considered very low. And all of these nutrient ranges came from UK's AGR1. And then here's some of the tissue samples. As you can see, none of the stands were considered low in phosphorus according to the tissue samples. About a quarter of the stands were considered low in potassium for the tissue samples. 13% were considered low in sulfur, 23% were considered low in magnesium, and 6% were considered low in boron. So just kind of sum up what we found. Soil pH was low in roughly 40% of the sampled stands. Soil phosphorus was considered low in about 5% of the stands. Soil potassium was considered low in roughly 35% of the stands. And according to stem tissue samples, all the sites were considered sufficient in phosphorus, and a quarter were considered low in potassium. So what this means is that this tissue sample seemed to indicate that the nutrient statuses weren't as low as the soil sample seemed to indicate. And that plant tissue data or plant tissue analysis indicated that sulfur was low at about 15% of the stands. So the next steps with this project is we need to summarize the survey results. So we sent out a survey to all the producers whom we sampled and asking questions about some of their management practices, alfalfa varieties, fertilizer, insecticides. And so we got to summarize those survey results, and we're going to sample at least 50 more stands next summer. We're going to explore the relationships between soil nutrient concentration and yield, and we're going to assess the relationship between yield and nutrient concentrations. Between soil and tissue nutrient concentrations. If you're interested in allowing us to sample one of your stands next summer, there's my contact information, or you can approach me after this and I'll take your name and your contact information. And with that said, is there any questions?